And so that could be a bad thing. The great aspect of technology and how change is so simple could make us unable to make decisions in the future. We've got too many opportunities for choice and change. So that could be something. But again, we're really just dealing with a current parameter that stops us from growing. We have to grow up.
A wise man once said.
A wise man once said.
The best way to predict the future
is to create it. You're about to experience a next level show. Scientists, entrepreneurs, thought leaders. You're listening to the Future of Humanity podcast.
Welcome to the show. I am your host, Carl Taylor, and I hope you've been enjoying the episode so far. This is episode 3 of season 1 of Future of Humanity. Now, if you are just joining us, I highly recommend that you go back and you check out episode 1, where we talked all about the future of electricity distribution through some incredible technologies such as blockchain, as well as episode 2. Check that out, where we discussed the hidden epidemic that we are all facing with our jaw structures that's leading to crooked teeth and breathing problems on an incredible scale. After this episode, make some time to go back and check them out if you missed them. Now, today I have the pleasure of introducing you to Dave Meney. Dave is the owner and director of Yenem Engineering Services, where they work with mostly mining companies to help them get the most out of their structures and, as a result, improve their production as well as ensuring their plant is code compliant. The reason that I got Dave on the show is he and his company are working on some pretty cool stuff in the 3D printing space. And what his company is doing is, frankly, a game changer in the mining industry with how structures are being built and how maintenance can be done. So in today's episode, we talk about 3D printing plastics versus 3D printing steel. We discuss the use of drones and online 3D models and how they're being used on a mining site, and just how the improvements that we're seeing in 3D printing are ultimately going to change the face of many ways that we currently do things. Now, there were a couple of issues we had with the audio on this one. There were some people sitting behind Dave in his team, in his office, and unfortunately, some of the noise they were making in the background was just a little too loud. We've done our best to clean up the audio, but if you have a few of those sections where you're like, there's background noise, apologies for that. We've definitely learnt for future episodes to ensure that that doesn't happen. So just wanted to give you that heads up. If you're like, hey, there's noise in the background, we are aware of it, and you shouldn't expect that in future episodes. So let's get into the episode. Thanks, Dave, for joining us. Super excited to have you here. You know, we've known each other for a little while now, right? Well, not known each other super well, but we've been connected on social media and travel in similar circles. And it's funny, today I had a brainwave or realization that the name of your company is your last name backwards. Is that right?
Yeah, it is. I've got clients they're probably as old as I've been working with them, and they still haven't connected that. And then there's others that see it straight away. So it's an interesting test, I think, an accidental test I've got to see how laterally thinking the person I'm talking to is.
Yeah, it's great. Yenem Engineering, and then Meney is your last name. So
yeah, that's right.
So yeah, look, let's talk a bit about kind of what you do. So your company is Yenem Engineering Services. Like, how long have you been doing that, and in general, engineering and what you do?
Sure. So structural engineering started when I finished uni in 87. I worked initially design office as one of 2 structural engineers. So I was just the newbie there, and we worked in an industry that serviced Alcoa mostly. So it was structural engineering work, but in a very mechanical and industrial environment. Not at all what I expected, I guess, coming out of uni and having learned a lot more about public buildings and bridges and those sorts of things. But I liked it and discovered it was a pretty good niche to be in. So after 5 years working there, I tried a few different contract roles at various companies around Perth here. Generated a bit of an audience of customers, I guess, of clients that wanted me to do work, mostly at night and outside of normal working hours. And so I got to a point where I was busier back home after dark doing engineering designs for a decent amount of money than I was doing my full-time role during the day. And I had to come to that crossroad and think, well, what am I going to do? I can't keep doing all of this. I was recently married and we were just starting to build a house, and I thought, well, it's either one or the other. And I decided to take all of the customers and slowly, I thought, build a consulting business for structural engineering. And things moved fairly quickly, and I never looked back. So
yeah, awesome. Like you just mentioned, slowly you thought, but I'm guessing saying it moved faster for you than you expected.
Yeah, I think if you start building a house and you want most of the time available to put into that, it's not going to happen that way. And Murphy's Law suggests I'd be a lot busier. And making money is a good thing before spending it. So, but it was successful, and for 11 years it was just myself. In a home office environment, which was fantastic, designing structures in my boxer shorts. And then about 11 years into it, I decided I wanted to pass on knowledge to other engineers, trained engineers, and I employed a graduate engineer. And that was quite successful. That was John, and he stayed around for about 11 years in the business. And over the time, we just moved from the home office to a nearby commercial location to an office. And we've had a number of staff, and people have come and gone.
The types of clients you work with is like industrial. Like, what would you describe? Like, what's the industry and the clients you're working with right now?
So we work in the mining industry predominantly, except for when the GFC came along and we had to make some adjustments. I'm happy to say we're sort of back busy with mining again. But yeah, most of our clients are mining companies or service providers to mining companies that provide equipment. Say screens and those sorts of things. So a very mechanically oriented client base.
Yeah. In this engineering space, and you're doing some really cool stuff, and I'm excited to kind of pick your brains about some of the exciting things you're doing in the engineering space. You've been doing that from what my research showed me, like going on, if not more, 30 years. I'm guessing in that time, is that correct? And in that time, have you seen the technology landscape change much in those 30 years, or is it more of a recent phenomenon that it's really starting to change in the technology being used?
Yeah, I think it's more recent. I think we've done a lot of the same thing for a long time, and I think that's still the case in design offices, really. Pulled out of the drawer and repeated and rebadged and over we go. I think the last few years, well, actually, I think it's downturn time that gets you thinking about new ways and smart ways of doing things, because it's important in business that we reinvent ourselves frequently to stay ahead of the rest.
Absolutely.
And I guess, unfortunately, creativity tends to happen when you're quiet and gets put on the back burner when you're not. So if we've been busy for 25 out of those 30 years, we haven't been doing a great deal of creating. We've been putting fires out, basically, just getting on with the jobs and wishing that we had more time to do things smartly or better or for whatever reasons different.
Okay, well, I mean, that's a great transition into you're doing some creative things in the engineering space right now, in particular around 3D printing. I also know you're doing some cool stuff with drones and modeling. But what I really want to talk to you more about is a product, I believe you call it Alt Connect. Is that, am I saying it right? Like, how would you explain it?
Yeah, having an idea and then putting a name to it is having an idea is a good thing. Putting a name to it is really difficult. I had a couple of other ones, and it'll make more sense, I guess, when we talk more about the connection. But it's a friction-based connection, and I thought Fricon would have been a good one, a frickin' good one. Absolutely.
Very Aussie too, right? I like that.
Yeah. Perhaps a little bit too colloquial, but so I came up with it's an alternative connection. So I thought, well, Alt Connect could work, and we started to write that into our media press releases and things, and then I googled Alt Connect because I wanted to register that name, and it's also associated with a Bitcoin thing. So, so I guess my immediate aim is to flood the market with Alt Connect, the steel connection, not Alt Connect the
cryptocurrency stuff. Yeah.
Cryptocurrency thing, yeah.
Awesome.
But it is. It's an alternative method of connection, connecting steel.
So talk to me about that, right? Like, so it is, as I understand it, you're essentially 3D printing steel, right?
Yeah.
Now, Many people who might be listening, they might be familiar with the idea of 3D printers who work with plastic. Is it essentially the same concept just with steel? Or like, talk to me about, firstly, how does it work? And then we'll talk into kind of why it was a necessary.
I'll talk about the connection itself just briefly and then lead that into 3D printing, because this whole concept of connection is only made possible, as far as I'm concerned, because of 3D printing in steel. And that is because of tight tolerances. So I've got a little demonstration thing here. I'll just hold this up to the camera. This is basically just an L-shaped column and beam that we've printed in plastic. But the idea of the connection is that you have two tightly fitted components. So you've got this, what we're calling the spigot, and then you've got this hollow section here called the socket. But basically, it's just one fits over the other. It's as simple as that. And the theory is that when you put bending into that connection, you give it strength so that it resists tension. So I'm actually pushing upwards at the moment and nothing's happening. It's not coming out like that. And it's that bending that's allowing that friction to really to bed in and hang on. If we were to manufacture that out of steel under normal methods, our first and biggest problem that we've always had is tolerances. So a 400 mil diameter pipe is not 400 mils in diameter, and it's not circular. So when you're trying to fit one of those inside another, you've got to give a generous amount of tolerance to ensure that the out of roundness and the out of tolerance in the dimensions still allows them to fit together. So at best, you've got a sloppy connection, and a sloppy connection is not going to give us what we need, which is a firm grip.
Well, a sloppy connection, I mean, if we put that in construction terms, right, a sloppy connection would be a building doesn't stay up, like a construction falls down, like it's not safe. Like, is that what we're talking about?
Yeah, it's not serviceable. I suppose if we build columns and put beams on them and there's a loose fit at every connection, when the wind blows, the building could drift a metre before all of everything's taken up. And, obviously that's not serviceable. So things to be tightly fitting. And 3D printing gives us that opportunity, albeit very new and expensive and limited in terms of size and so on. It's an emerging technology. It's been around some time and it's getting better every week, really. So it gives us the opportunity to create steel components that we would otherwise have to mill out of a machine and start with a big, huge piece of steel and mill it down. And who would do that? I mean, that's just an overly expensive exercise.
That's an interesting thing. Like, what was the process before this? Like, what is currently being done, or what were you doing before you had this option available to you? Like,
yeah, no, it's a good question. So where did the whole idea of doing this differently comes from?
Yeah.
It's really what you're saying. I suppose for years and years we've been building in mining structures. We're doing them the same way. So we're designing them out of beams, columns, braces, and so on in the computer. We're using standard connection concepts, which is just cleats and bolts and welds.
So for people who don't know what bolts and welds might make sense, but what about cleats? What exactly?
Plates welded to beams that allow you to connect one piece to the other with holes drilled in it to allow it to be bolted up. So all of those items would go to site out in the middle of nowhere somewhere with expensive labour, and then they would be put together basically piece by piece. And so there's got to be a better way of doing things. And there's modularization. So for years now, we've been looking at modularizing structural components, building floors rather than beams, building whole structures rather than single sticks, and so on. But then you've got other issues like the volumetric space in a ship and the cost associated with volume over tons. You've got wide loads making transport of these things difficult, and so on. So
yeah, right.
Old IKEA and their flat pack concept is probably the idea around.
It's IKEA for full building.
IKEA for steel structures.
Yeah, for steel structures.
Yeah.
Great.
And it's a good analogy because IKEA's furniture is amazing the way it all joins together, almost the same concept without nails and hammers and nails. Things are pretty are clicked together or pushed together or whatever. So we're looking at a flat pack idea. That way you can transport pieces as opposed to huge big items, but still be able to handle them much quicker on site.
that's quite interesting to me because, I mean, sometimes you might think, well, if 3D printing can do this with all these other, not just plastics, but with steel, why wouldn't you just print the whole structure? But as you've said, like clearly that's an issue of, well, how do you transport it from where it's made? I mean, is it possible though that could it ever at some point in the future be printed on site completely in one thing? Is that a potential future thing, or are we years away from that ever happening, or you don't think it would ever happen?
I think it would. I mean, if you ask the question about a little Nokia phone, could it actually tell us the temperature one day, or could it tell us an email one day? These sort of questions get answered over time. There's got to be a reason for it. It's got to be practical and useful. But on a mining site, let's use mining. It's my area of expertise. You need spare parts. So every conveyor needs spare idlers. And you can't have a whole array of these different things in the workshop. So you've got to standardise on components. For every plant that you build, you've got to provide a whole pile of spares so that they're available. If something goes wrong, then you don't have, there's no time to wait for something to be shipped or flown to site. So there's definitely a case in the future where you need a new part. You just put your requisition order in and the printer starts up, goes all night, and you go and grab your component when it's ready. And
print it on site, on demand.
Yeah, absolutely. So storage becomes tiny. You've got a room with a printer in it and a whole pile of material for printing, and you wait for the time required to do that. So yeah, I think that the future, even just looking at non-metallic parts, the plastic printing industry and so on, that's really becoming quite a thing. I love the saying about 3D printing. It's dream it, print it. So that's possible with printing. If you can model it, if you can visualize it, and you can model it, you can create it. And you can't do that with normal manufacturing methods. We're stuck with our steel beam lines and our bolts and our welds and everything being orthogonal. So it's easy to analyze and design for us, and that's really restrictive. It doesn't give us scope to have amazing different things.
So does that mean that by being able to 3D print steel structures now and not just plastics and such, like being able to 3D print with metals, does that mean that previously possibly impossible types of structures are now possible? Like, does it fundamentally change some of the dynamics of what can be done that in the past with the traditional ways weren't possible? Or is it more just a matter of making things cheaper, faster? What does that impact?
Yeah, cheaper, faster, lighter. They're all requirements for an end product, whatever that end product is. The one that comes to mind is one we found a couple of years ago when we started this research. And one of the airlines wanted to investigate 3D printing and the modelling that goes with the 3D printing to minimise the weight of the seats. And I think specifically these were the fold-down seats that the hostess, the airline staff use when they have to anchor down.
Yeah, right. The flight attendants, they sit down and stuff. Yep.
And as we all know, in a plane, we're talking, kilos are important, not tons. So modelling of the support structures for their seating was done using modelling that followed the important stress paths and only designed something that carried the stress an optimal way. So the result was a very weird looking thing behind the fabric. It wasn't just two vertical steel struts with a horizontal bit and so on. It was a very interesting looking thing because it was just providing metal where metal needed to be and holes everywhere else. Now you can't fabricate that with normal methods. You'd start with the big heavy lump and then you'd start drilling and cutting holes all through it. Now why would you do that? And that would become unnecessary. So
it really kind of changes those of you who are designing these. It gives you new options and kind of changes the way you think about it. You're no longer restricted just to I have to connect these pieces together. It's what if it was all one piece?
Yeah, and it makes it quite hard to even visualize and create those things because we're hardwired to think conventionally, aren't we? So any new thing is really just I think these days anyway, it's innovation, not invention. Any new thing still comes from a traditional concept. It takes time and other people's contributions and everything to end up being something completely different in the end. And I guess our little connection here is completely different than the one we sketched up some time ago before 3D printing came about. And it was our roadblock. We've got all these pieces of steel that are meant to go to site and be installed very, very quickly. And we're using more bolts. We've got all these packers. It's crap. Like, what are we doing this for? Who needs this? And that got shelved, and 3D printing came along, and the light bulb went off again, and I thought, well, wow, you can actually do this now. So
the idea came, but the technology wasn't readily available or in existence yet. And then when it came along, you could bring the idea back. I love that. That's so great. Yeah. One thing that I've been curious about is, let's say the current way of doing things with welds and bolts is by a fully 3D printed piece, or as the connections that you've created where they kind of connect together. In my head, when you were describing it and visually showing it, it was a bit like a pen lid going on in a way. And is that safer, exactly the same, or less structurally sound? I'm guessing it's not less structurally sound. Like, let's say earthquakes, for example. How does the 3D printing stand up against, like, if you're in an earthquake-prone area? Is it better, roughly the same, or what is that like?
Yeah, no, it's a good question. I suppose it's not so much about the 3D printing, it's about the type of structure. So actually in earthquakes, the structures depends on the stiffness of the structure as to how much load it attracts. It's a little bit different than if you just jump on a beam, you weigh 80 kilos, that's the load that's going into the beam and so on. But an earthquake, if you've got something very stiff and resistant to ground acceleration, it's going to attract more load than one that's a lot more forgiving, if you like. I suppose it's like the old FJ Holden versus the resisted impact versus these new cars that crush so easily. And as a result, the driver stays alive because the forces are so much less. So in an earthquake situation, a sway structure is actually a pretty good idea. And a sway structure just simply means you've got beams and columns that are connected strongly together so that they resist bending, as opposed to, say, a truss or something like that that's got a whole pile of angular elements in it, which becomes a lot stiffer, moves less, but it also attracts a lot more load in an earthquake.
Sorry to interrupt. Does that mean that with 3D printing, it's easier to create sway structures, or is it no different? I'm trying to understand, does 3D printing make things safer, or is it really roughly the same and it's really about that cheaper, faster kind of manufacturing process?
Yeah, I guess the 3D printing of this connection isn't to enable a structure like that to be built, because we would simply just do that now with a beam, with a column and a bunch of bolts. What the difference is, the way we currently build structures, you've got to erect scaffolding, people have got to work at height, you need to crane in every single beam. It's a slow process. The idea around our concept is that you can build floors on the ground and then you can just lift columns into position with a crane and drop floors straight over those columns. So grabbing this again, if that's a column as part of a structure, there might be 4 of them, then a crane can just lower that segment, which may be a whole floor, and it would just fit on, and there's no scaffolding, there's no workers at height, and there's no several weeks of erection. So
that's the speed difference. What
speed and safety?
Give me an example of the old way of doing it speed versus your way of doing it speed.
Okay, so you just saw that I put a beam onto a column.
Yep.
If you picture the Meccano sets that we used to have in our toy box,
yep.
You'd be fanning around with a nut and a bolt right now, and you're probably still putting that beam onto that column. So that's the difference.
So are we talking like something that would take weeks can be done in days? Or
yeah, I think so.
So I mean that fundamentally changes how quickly as a society we can continue to kind of build and I mean in your particular situation with the mining, I suppose that means getting something new up and running can be quite fast, and time in business can often equal money. So the faster they can get up and running, that's a competitive advantage for a lot of your clients.
Yeah. And then you start thinking of different things. So, for example, if you're trying to put one piece to another, in our example where the connection, you've got the 2 pieces, you can embed a little wireless transmitter into both of those pieces that are aligned when the thing's installed. that signal could be relayed back to the operator that can confirm that the connection is being done properly. So it's fully bedded down, if you like, and connected.
So you're saying there's a sensor inside or attached at the same time of connecting it. Is it in a way like your quality control, your QA of checking it's been done right?
Yeah, it could be the quality control. We're starting to put sensors, this is called the Internet of Things in common language. So we're starting to look at putting all different sorts of sensors into all different things. Computers in fridges is probably where it all started, and we now put sensors into bridges, for example. So the asset owners of bridges can monitor loads and performance of the bridges over time. And certainly on a connection like this, all we need to do is provide a little space inside the connection for two sensors, one on one piece and one on the other, and a little program that knows when they're both touching each other. And later we can use those monitoring devices to just keep an eye on the stresses on the structure, so that if the wind is particularly high and the building's swaying, we can look on a computer and see what the stresses are in the structure and whether we have a problem or not. So,
wow.
When you do something different and you tell somebody, or you read something, it's, hey, we could do this, we could do that, and things then snowball if you let that happen.
Yeah, and so I mean, this Internet of Things, like I'd never even thought about. It makes so much sense now you say it, but I'd never thought about putting Internet of Things, Internet-enabled sensors on something like a bridge. I mean, we've heard in the news recently about a bridge that collapsed. Now, had that had sensors, maybe that would have been detected far earlier, and that catastrophe could have been avoided. We're not just talking about smart homes inside our homes. We're talking about a future of potentially the buildings themselves being intelligent and sending data back to monitoring stations, and then you combine that with, say, AI. This fascinating stuff.
Yeah.
Let's talk a bit about that. I mean, I know you're doing some cool stuff with drones and modeling as well. Can you quickly touch on that? Let's touch on some of the stuff you're doing with you've got drones essentially going around and taking photos, scanning to create these 3D models. And then I believe they're connecting to some of these sensors in the building. Is that correct? Like, talk to us a little bit about that.
Yeah, I'll give that a go. So certainly in our business, we do structural audits. So we're looking at old structures that are falling apart or getting close to doing that. And so that's one of our service offerings. So we have a client in New South Wales, out in Cobar, and in that particular instance, there's a number of concrete bins that are about 60 years old and various levels of degradation. And so we won that job because of an innovative thought to abseil down the side of it. And I like abseiling, so it was a no-brainer for me to put that in competitive price for that. And so that's what we started doing when we were assessing the bins, was to just hang off the side of them and have a good look at the concrete. And we still do. We have a 6-monthly job to inspect these bins, and the third time we went back, we decided to use a drone. And so our structural engineer, John, stood next to the drone guy, and basically in the comfort of the ground and safety of the ground, he had a good look over all of the parts that we hadn't been able to get to, either with a crane box or with the abseil gear. So that's how that's a fundamental use, I guess, for drones in structural inspections. Always wanting to offer more. What can we do with these drones? You can create 3D models from the data that you capture from drones and even from fixed cameras. And we've been playing around relatively unsuccessfully with that for some time. So we've got a whole bunch of photos, and we've created kind of a Call of Duty walkthrough game of our structures. And what we want, what we're still trying to pursue, is the end game. Is that the boardroom's full of stakeholders that are actually interested in their assets, and without thumbing through, and I've got to say it, they're our reports, but without thumbing through a 100-odd page boring report on structural problems, looking at photos and our sentences saying what should be done. What I'd much rather people do is use a mouse or a joystick and surf through their structure. And when they get to a certain area, there's a little pop-up box that says this is no good. You've got a month to fix it. And, from there, it's endless again, Carl. You can click on the box and get a work order sent straight to needs to receive it. And all of that can be done without thumbing through boring old reports, because what we found is that people don't do that. So quite often observations become recommendations become forgotten.
Interactiveness. Everyone we like to be involved. We like to be interactive. And I can definitely see that. I mean, no one wants to read those boring reports. They might have to, but they don't really want to, right?
Yeah.
So to be able to have something that feels more like a computer game, and I, you sent me a link to one, and if I'm allowed to share that with the show notes, I will. But that was really great at visualizing just how easily you can kind of explore this building, as you say, connecting that back then to, hey, there's a problem here, and being able to then 3D print the new piece, or to put in a work order for someone to go in and fix it, or like that's pretty amazing. Let's talk about the future. I mean, like with what is happening just in your industry alone, if we project out 10, 20, 30 years, what do you think the impact of all of this is going to have, not like on your industry, but also just in society in general? How's it going to impact our cities? How's it going to impact jobs? What do you see when you think to the future?
Yeah, I don't know. I can talk about where we're heading, I suppose, in our industry. I can see so much more 3D modelling now than the old way of doing things. Certainly, we mentioned I've been in this business for 30 years, so we started with drawings on drafting tables and A0 prints, and then CAD came, and that was fairly new into when I was a younger engineer. CAD came, and some people said, I'm not learning CAD. I've only got 5 years till retirement, and of course you couldn't ignore it. Everything started to become drafted using two-dimensional computer drafting packages. 2D has become 3D, and the latest thing that's happening now, by some and not by everybody, I suppose, so it's the current future thing, future, if that makes sense, is modelling bits, modelling. They call it BIM, so it's building information modelling. So things are put together as objects. So in a piping system, you might have a pump, you might have a flange on both sides of it, a bit of pipe on both sides of it. All of those things are objects with predefined parameters, so diameter and length, just as an example. A pump might be a particular manufacturer. So if you imagine drawing that back in the day, and then someone wanted to change something, everything would have to be redrawn. Currently now, everything's a database-driven thing. So you'd wander over to the draftsman and you'd say, we're going to use a Warman pump, not that brand. He'd say, no problem. He would replace the pump, and the entire drafting package would update all of the dimensions and everything that changed because of that. Anything you can think of that changes pushes everything else around. And of course, in the background, the computer software is doing clash detection. So if you chose something too big and it struck a column right nearby, then you would be alerted to that, and you'd have to deal with that. So you might move the whole thing half a metre one way, and again, the whole thing would change. The biggest hurdle we've now got with companies that are starting to use that technology to create plant designs and things is the lack of any drawings. So it becomes a debate on how are we going to sign off on these things. I mean, we're used to looking at a drawing and putting a signature in the box. So now how do we do that? And these are issues big enough to squash any idea of using this sort of technology with the current decision makers.
And I suppose in some ways, if it's so easy to just swap out a part and change things, deciding when it's done, it's like, no, we're not changing anything more. I can so see that. It's like, oh, well, it's just a simple change, right? We're not that far along. Surely we can make the decision now to change this. So yeah, getting that final closure of saying, no, it's done.
Yeah, absolutely. That can become really hard. And I mean, the best project manager is the one that draws a line and says, that's it. We're not doing it any other way. We'll have our opportunity again. We've got to move on. And so that could be a bad thing. The great aspect of technology and how change is so simple could make us unable to make decisions in the future. We've got too many opportunities for choice and change. So that could be something. But again, we're really just dealing with a current parameter that stops us from growing. We have to grow up and deal with that. So we can't sign a drawing anymore. I'm sure we can get around that. There's another way. So, I mean, we're doing that in our office. We approve a model of one of our clients, and we take a snapshot of the model. We note its timestamp, and we sign a piece of paper basically with a little snapshot on it that says this is the model we've seen and we're happy with. If you change it in the future, I guess I've got a little bit of paper that protects me. So,
in the future, you could potentially link it in with the blockchain and then use the blockchain smart contracts to say it's done. So, if you want to really connect it into the future, that might be a way you could go. It'll no longer be pieces of paper signed; it'll be signed through the blockchain ledger, possibly.
Yeah.
Wow.
I think the future is going to be one where we create more, because we've got the options become a lot endless, really. The manufacturing constraints have just disappeared because we can print anything, and we can model everything. The customers can see what they're getting before they order it. In the case of a house, no one has to read house plans anymore. I think for ages now, if you've been a new house purchaser, you've sat in the office of the builder and had a look at your house fully furnished and walking from room to room, and that's how it is now. So if not everyone's doing it, we'll see that soon, and so it allows us to visualize things and create. The 3D scanning thing, the 3D modeling thing, was demonstrated to us by Meney Systems, one of the big worldwide companies for software development, and they had the gig to plan out I think it was Philadelphia, when the Pope visited America. They scanned the entire city of Philadelphia into a computer, and then they used that computer model to create the road transport plan from the airport to the city hall, and they did everything in a virtual world. They actually put the crowd there, and they went through every possible scenario, security and everything, based on a whole bunch of photographs from an aeroplane. Basically, is how that started. And there was a few dollars behind that, I imagine. But as that technology becomes more and more accessible to everybody, it opens up so many possibilities, doesn't it? So,
absolutely.
It's hard to answer your question about what the future will look like.
Well, I think you have. I mean, it's showing that the ramifications of 3D modeling, as you've just talked about, the ramifications of 3D printing of metals, and it's going to just continue to snowball. I mean, I personally have envisaged a future where we at home have our 3D printer who maybe it can straight out of atoms create anything it needs. You don't even need different things. It'll just be able to manipulate different atoms to create what you want.
Yeah,
why would you go?
That's actually very scary. That's actually very scary, isn't it?
Absolutely. Yeah. And it's a potential future, though. I think that really we could see, and what you're working on is some of the forefront of that, and actually using it in day-to-day applications. We'll start to wrap up in a second. So, I mean, I suppose one of the key questions I'd love to know for you is bring it back from the future and talking more about where we're at now and the things you're doing now. If you were to give, let's say you were having a conversation, maybe one of our listeners is a young, smart, driven person who's just come out of their engineering degree, or they're just going into university, or they're looking at their career. What would you, with what you know about what's happening in your industry in particular, what would be your advice to them to be able to stay on top of where things are headed as well as where things are at right now?
Yeah, I suppose we're all getting wrapped up into this whirlwind of fast track projects and everything. It's hard to give advice to a graduate to not get wrapped up in that. I mean, I'm probably guilty of wrapping my graduates up into that same whirlwind anyway, but to just work in a progressive company, I think, and someone or a company that's open to change. It reminds me of my first interview, Carl, where computers were new. In my final year, I bought an old, well, it was a new computer then. I bought a computer to do my project with, and I was quite keen on computers and how they were going to change the engineering profession. And so I went to Connell Wagner, which is a highly respected Australian company, and my question to them was, what's your thoughts on computers and do you use them? And the answer was, we have one computer which we allow the senior structural engineer to use as a checking tool, but we don't allow our staff, our engineers to use it. And I declined the job offer with Conal Wagner because I just thought that was a silly idea. We're talking back in the days of Tandy computers.
I remember Tandy. As a kid, I used to love going to Tandy and play, buying the little kits and different things from there. I was a real geek as a kid going to Tandy.
Yeah. So choose someone that's a progressive thinker. I think is important, and then don't feel that you're not that yourself. So your contribution as at the beginning of your career is just as good, if not better, than those at the other end. I mean, young people are so much more open to new things than old people. So. And that's the thing. That's the biggest challenge we've got ahead of ourselves with Alt Connect is change and the reason for change. We need a shock to change generally as human beings. We don't just change for change's sake. So I think that's the biggest hurdle.
So what kind of a shock do you think is gonna need to be required to create the change?
Yeah, I don't know. I think just a lot of hard effort on our part to demonstrate the safety and the cost benefits and the time benefits associated with it, and then thinking beyond what we're currently thinking beyond mining structures to commercial and residential development. Perhaps we can throw up a post-disaster structure very quickly using something like our connection technique that would obviously save our lives because people would be housed sooner rather than later. So,
disaster relief. That's huge. That's a huge benefit. I can see. Wow.
And so I guess that's why I appreciate this podcast because the audience needs to be vast and diverse for everyone that's listening to hear their version of what's coming and what could be done with that. So.
Absolutely. Yeah. Well,
I was thinking before you thinking about visualizing the future. It always brings me to a memory in our Perth museum, which was shut down for a couple of years while they rebuilt it. But there was a big mural in the museum that was created. I don't know when, probably not long after the first planes, and it was a mural of the city in 100 years, I think. And so there was a number of buildings, none more than about 3 or 4 stories. And there was this massive aeroplane in the sky, which is very visionary, but it was a biplane still. So they hadn't moved past the concept of needing biplane wing technology. So looking into the future with the present that we have is a bloody hard job.
Very true. Very true. Very wise. And so on that note, we'll wrap up. But thank you so much for joining us and sharing with us what you're doing. And for any of those listening, wondering what some of that background noise is, Dave's in his office and he's got his team members busy working away. So if you're wondering what that was, that's what it was. So if anyone wants to kind of stay in the loop, get in contact with you because they're excited or interested in learning more about what you're doing, what's the best way for people to kind of stay in contact and stay up to date with what you're working on with everything you're working on with Alt Connect and everything?
Yeah, well, we're updating the website at the moment, so certainly within days, if not weeks, we'll have the new website up and running. But the current website is yenem.com.au, and that will put people in touch with us. You can join our mailing list, and the best thing would be to just either send an email or grab the phone number and give us a call and tell me what you want to know.
Perfect. That's Yenem, which is YENEM.com.au. Yeah, reach out. And if you're an international, you will need to add in your international dialing code. For Australia, it's +61 if you're calling them from an international number, but maybe email is the easiest thing to do. Again, Dave, thank you so much for sharing with us, what you're working on. I wish you the best of luck. I'm excited to see. And next time I catch up with you, I want to hear about the what's been happening, what new innovation you've made with Alt Connect and your 3D modeling. And I'm looking forward to you telling me that you've integrated it with blockchain to make the sign-off process work. That would make my day.
Thank you. It's a pleasure.
Awesome. See you later.
Cheers. Thanks.
Thanks for listening to the Future of Humanity podcast. To download the latest episode and find the transcript and various resources mentioned in today's episode, visit our website at foh.show. That's FOH as in Future of Humanity and show as in SHOW. You can also, via our website, contact me with any feedback or suggestions for future episodes. So please do reach out. Now, if you haven't already subscribed, you can find the links to subscribe on all your favorite platforms at foh.show/subscribe. That's foh.show/subscribe. And more importantly, if you'd like to continue the conversation from today's episode and connect with other listeners, then you can join our free community at foh.show/community. foh.show/community. I look forward to seeing you there.